exam next week, Thursday. So, this will not show up on Thursday's exam. It will be the beginning of what we're going to be continuing after the exam. So, just the way that the schedule worked out, this is what we end up having to do. So, we're going to talk graphs and stories today. We're going to do the stacking cups experiment, and then I'm going to introduce to you the Algebra 5 project. Okay. So the first thing we'll do is we're going to take a look at a couple of graphs. In general, in your groups, what you're going to do is you do not have all of the information for this graph, but in your groups you're going to make some decisions about what's going on, what's happening in this graph. Let me slide it, scroll a little bit so you can see a little more. So we have the fact that John and his dad are in a race. John starts the race 3 seconds after his father begins. The graph gives you information about how far John and his dad ran over time. You don't have to write stories, but in your groups, just sort of talk about what's happening in this situation. It says, write about who won the race. So talk about who won the race, how do you know, be descriptive about how the race is run, like each of them is running. And then if you have time, and I don't know if we get to it, but if you have time, if the two lines are going to actually be parallel, if they were parallel to each other, what would that graph tell you? Okay, so in your groups, talk about this graph. So that's okay. In your groups, talk about who won the race, how was it run, how did each of them run, and so on. Okay? So remember to give examples, justify.
Even though he's starting later, it looks like he's or maybe if it says 100 meter race and he finished it faster, he did. So John won the race. Yeah.
All right, so some stories. It doesn't have to be story form. It can just be. All right, so we don't have any 1, 4 of clubs. Who's your club?
I think I am.
Okay, so what? Who won the race according to your groups? John ran the race. How many people thought? How many groups thought John won the race? Yeah. Okay, so I'm going to ask that. How do you know that John won? 5 and 10?
Because like we looked at the graph and like even though John started later, like he caught up to him by like the 70-meter mark, and like if you just look at the lines, like he finished 100 meters, like his
Go with what you said.
like his lines like shorter on the time, like the seconds. Oh my god, I can't speak.
It's
but
hard to explain this, isn't it?
it's like not as long as the depths. Like if you look at like the seconds.
So I heard you say John reached 100 meters.
quicker than
Yeah, and I heard he said 17-ish. I heard a 17 somewhere.
Well, I was talking about the meters, like he caught up to him around like 70 or 80.
Oh, 70. I got you. 70 meters. He caught up to his dad, and then continued running, but he finished earlier, and so I was thinking 17,
Oh, yeah.
16, 15-ish, that he finished that many seconds. Pretty nice speed. Dad, way to go, Dad. He's hanging in there, right? Okay, so how is that race, how is it run? So I'm just going to take some volunteers. When it comes to Cassidy shared a little bit of an example of that. Like she said that John started earlier, but later, but then finished earlier. Yes?
Well, John was running faster than his dad because you can tell by the slope of the line, that's the speed at which they're running. And since his line is steeper, that means that he's running faster than his dad.
Okay, so I heard a couple things. So I heard John's running faster. The slope of his line is steeper. It's not way down as much as steeper, so it's the rate at which he was running. Is that what I did?
Yeah, it's faster.
So it was faster, so he's running a shorter distance, a shorter time, because it's going up higher. If you go more a slope that's flatter, then the time is going to be longer. So if me running the 100 meter would be more like, and so I would be slower because that slope is flatter. It's not so steep. Okay? All right, next graph. Coming up with a little story for this. There's a relationship between profit and the amount of lemonade that's sold at the lemonade stand, okay? And so you're going to come up with a story explaining how the lemonade stand's profits decided, okay? Explain what's indicated when the line is below zero, so there's some stuff below zero, and when the line crosses that horizontal axis, and then that little ziggy-zaggy that's up there, that's the technical term. What's happening there? So you guys are going to come up with a scenario that would make sense, like, what's going on over here? This is how much sold, this is how much profit there is, okay? What's happening here when it crosses that horizontal axis? What's happening over here when we have the little ziggy-zag? Okay, go in your groups and talk about that.
Okay, you're not fit. But I feel like you can still sell it for. I feel like I'm saying
Wouldn't it be that they were and then slowly grow?
yeah. It's so recording. Like,
I know
or
Okay, let's talk story. Once upon a time, there was a lemonade sale, and no one. 3 clubs. Like, oh, that's probably Sicily, right? Of course it is.
I'm hearts.
I'm done.
You're done. Are you staying?
Yeah, but I'll just go.
Oh, thanks, baby.
So below the line, it was just when. Below the line, it was just when they had to buy all the materials and they weren't getting enough. There more, making profit.
Well, would you agree with that?
Yes.
They're not buying all that stuff that they need, you know. If you're me, then it would be like the canister of Country Time lemonade or whatever, and the water and the cups. That's all I would be. But some of you all would be like lemons and sugar and actually make the lemonade. I'd be like, here's the powder. Okay, so then, thank you, Brenda. 5 of spades. What's happening at that 0 mark?
We talked about that being like when they ran out of their supplies.
Right here,
Oh, I'm sorry.
at the 0.
Oh, when it
When across the 0 line.
that's when they started making their profit because they were selling. They continued to sell because of the upward diagonal.
Selling.
And then once they crossed the 0, they were able to make a profit.
Okay, so down here, that was negative because they spent their money on those whatever they bought, and then they're in the red, right? And they finally got to get into the black. Well, and the line is like break even, right? Okay, 3 of spades. Oh, never mind. 6 of hearts. I want to do hearts. Okay, so what's happened at the ziggy zaggy?
The zigzag is, we said that they ran out of product, so they stopped selling and she had to buy more product, which lowered her profit, and then she excelled again because she had more lemonade to sell.
Anybody have that same story going on? Anybody have something different? This is where creativity comes in. Larissa.
I thought that they just nobody was buying anything, but then they are losing money, so that doesn't make sense, I guess. Right?
So you just process through your own response. That's how I am. That's called verbal processing. And you're like, oh, never mind. You're right. There would not be a loss of profit. It would just, if it were a time instead of amount sold, then that would make a difference.
Yeah.
Any others? Go ahead.
We said that someone pocketed the money, so.
There we go. Someone's a thief. Pocket the money, whoop, and then they just kept on selling. Nice. Anything else? I've had pocketed. They were actually like robbed. Somebody came in and like stole, not just the person like running the sale, but some customer came and snagged some cash and bullied them out of their lemonade money.
I said she broke the jar that she had the lemonade in, so she had to restart.
Hang on, say that one more time.
I said that she like broke the glass that the lemonade was in, so then she had to go like
Buy another.
no, she just had to remake it, so she lost that money.
Oh. Okay.
Product.
Broke it, spilled it. I heard like someone else do that. She said they spilled it, so you lost profit. Okay. Fabulous stories, and then we'll just do one more. Okay, this graph actually is about a flag that's being raised, like on the flagpole, and so describe what's happening, and then kind of give an estimate, like what's happening with all this stair stepping stuff, and then give an estimate for the height of the pole. Okay, go for that. Talk about that. What's going on? Yeah, I see a lot of this going on.
Really high pulse. We're just like,
Yeah.
It takes so much grace.
either that, or you
Yeah, like maybe it's going
I was
up.
thinking
Yeah. Let's say 25 each time it's going up.
All right, so let's sort of talk through this. Let's talk through this. I know that everybody's coming up with their complete story. Here's some. So, what's happening with that flag? So, 5 of hearts. What's happening with that flag?
We said that someone was like pulling it up, and then they got tired, so they take a break, and then they pull it up again, and then they get tired, so they take a break, and then they keep going and pulling it, and then like as it like got taller, it would take them more time because they could get more tired.
Although I notice that the increment between the tired, so the tired would be like where it's like flat-ish, looks like it's about the same. Each one looks like about the same. You know, I'm like seeing they're about the same. So, Christina, what do you think?
Well, we said that it was a group of first graders, and they all were taking turns and they got to pull it up 2 feet each. So then,
So you're just making it.
yeah,
Perfect. Well, we made up the story.
And then they did it, and then once we got to the top, there was only 5. This turn was 5 turns on this graph, so it's like 10 feet tall. So that's
Okay. There we go. Okay, Liz.
We were saying it's like the same person pulling it, but instead of like pulling it a lot and taking a break, like every time you pull something, you like can only take it so far before you have to like reach like to the top, not to the top, but like as far as you can
Regrip
to pull
again.
it again. So we were saying since it is consistent and it's the same person, it's probably them just like pulling it and letting go and like taking the same amount of time.
So,
yeah.
okay. So if that's the case, then would that make sense? Like
Just doing like
my
one
pull
time.
is going to be about the same every time, and depending on the height of the person or the length of the person's arms, you know, then the estimate for the height's going to be different. So about how high would you say, using that story, would each increment be? Did you guys come up with one in your group? So each one of those. So yeah, short arm, just one arm pull because it's like this. So it's like I was gonna say like 2.5 feet for me maybe, but if you have someone who's taller, it could be like 3 feet or 4 if you're real tall and you pull it down. So you could always justify those lengths of arms or pulls to do that. So even though we don't have all the information, we can actually pull a lot of information from just the graph itself. So that leads us into what we're going to be doing. So up until now, what kind of representations have we had when representing your work? Showing your work. What are different ways people represented work? Just volunteers. Go ahead.
Pictures.
Pictures. That's another way people represented their work. Tables. Tables? Would you agree? Pictures, tables? Wait, I had one more. Oh, yes. Something with numbers? Equations. I'm like, I'm missing one. Pictures, tables, and equations. So this is kind of getting us in a mindset that we're going to start moving towards graphs. So pictures was the real basic, and then we moved to doing some tables, and then equations. So now we're going to move into some graphs. So before we get started with our experiment, let's just talk about this graph. So we have 2 axes. Instead of axes, A-X-I-S. And X-E. Okay? So we have more than one axis. How do you like that? We have an x-axis and a y-axis. So just as a review, this would be x, and this would be y. Okay, so in elementary school, when we start doing this in 2nd grade, we actually are talking about x-axis and y-axis. And actually, I'm not sure about when. I don't think it comes up that early now. I think it's a little bit later.
I did it in 4th grade.
4th
And
grade.
I remember because she like literally was like doing this. with her
Okay,
wrist.
so that's what I'm going to do right now. So when it comes to the y-axis, we do this. Y. It stands up very tall.
That's cute. We say Y to the sky.
Y to the sky. There we go. And then X. Then the kids are like X. And you're making the X, so it's kind of making that horizontal motion. You're making their X and the Y axis to kind of differentiate between. So she's going like X and Y. And then okay, so they did Y to the sky, Allison. And what did they say for X?
I think we said it was like train tracks. Like crossing.
Oh, train crossing. Okay, so train would go across. No, she's making it up. It's a good one if you made it
I
up.
knew it was Y to the sky. I just that one was happening.
So the x-axis and the y-axis. So when it comes to what's represented on the x-axis, think about like the tables. Okay, what do we typically have the x-axis be? Would it be the input or the output? X is usually the input, and that leads to then why some of your work, if you go back to like a little bit later in your math world, X was on the left and Y was on the right because that's your input, and then Y would be your output. Or if it's set up this way, the X would be the top. That's the input. So the x-axis is usually the input, and the y-axis is usually the output. All right, so we're going to do a little experiment. And you're going to use some materials. We don't use a lot of materials in this class. But so you'll need to have your stacking cups experiment document. That was very nice of you, by the way, Reed. I saw you like you're the provider, taking care of your people. Yeah, is that your job? Self-side. Self-side.
Oh, she's carrying. I have a printer.
All right, so here's the deal. You're going to each of your groups. You will get a 1 measuring tape and 4 measuring cups. I'll put that on the bottom now. 1 measuring tape, 4 measuring cups. So when you come up, send somebody up. Or send someone up to get each material. It says several, but only use 4. We're using the metric part of the measuring tape. So we're measuring in centimeters. If you take a look at your table, first you're going to measure the height of 1 cup. And it even says on that table that it's in centimeters that you're going to measure. So here's the deal. When you're measuring your 1 cup, you're not measuring the cup like this. Although that wouldn't work anyway because there's nothing on that side of the measuring tape. You wouldn't measure like this because, oh my gosh, this person rolled this really tight. My geometry class. We just did them last week. Okay, if we measure like this, is this the height of the cup? No, because that's like diagonal. It's not the height of the cup. It would need to be perpendicular to the tabletop. Okay? Because if we go like, because this is on an angle, this is not the height of the cup. The height of the cup is how tall is it? Okay? So it's not going to be perfect. If you're a perfectionist, so sorry. So sorry. So measuring in centimeters, so then the millimeters would represent tenths of centimeters, right? All right. So you're going to measure 1 cup, record it on the table. Then it says, place a 2nd cup on the stack. That would be like this. You can have it like this, or it doesn't matter which way you have it. But it's not like this. We're not stacking this way, we're stacking inside. Okay? So then you'll measure 2 cups. Record it. And then you continue until you finish your table. Okay? So, and you record those there. Basic. If you will get started with that, send somebody up to pick up a measuring tape and 4 cups.
Feel confident measuring? Yeah.
He says. She's not actually here.
So go ahead, please take turns and check each other's measurements so it's not one person doing everything. Okay? So don't go well. Very serious.
Alright, sis. What's 1 cup? You have to check my measurements. Not straight up and down.
No.
It's straight as it's 9. Do we have to assume 1 decimal? Like in chemistry? For sig figs? Chemistry is good.
I think it's 9. Anyone want to confirm?
That's what we got.
Okay. Oh, was it millimeters?
10.2. Oh wow.
You wrong. So this should be 11.4.
It's more like 0.5.
We're saying 11.4 because that's what
Yeah, 11 and a half.
So sorry.
I'm gonna say 11.5.
No, because you have to write an equation.
Let's see what this one is. You want to try and measure?
No, I just want to do importance. It makes the equation easy.
You took. Oh, good. I'm like, wait. Wanted to make sure you took that.
You want this one to be 0.6?
Once you finish your table, go ahead and continue. Once you finish your table, continue with the work and your experiments.
Wait, so this part is
Sure. That's close enough to 0.6.
12.6?
That's great. Let me get one ratchet.
Okay.
So these are going to be line graphs.
This will be
Alright, I'm gonna tell you.
X is the number of cups.
So let's start at 9 and then go to 9.5. 10.
She said,
11. Doesn't really work.
Continue on with the graphs.
well, our data just doesn't make sense, so we're trying to do a read.
Oh, you're remade.
Yeah, we're just not sure.
So this is really.
How are you related?
One of them was a one centimeter.
Oh, it does.
One was a 1 centimeter.
So it is as well.
I just have to.
Like 0 is
How we doing?
Alright.
All right.
Not
With
enough
the
lines.
questions,
Yeah, there's not enough lines.
you gotta change the scale then.
Like,
They're not gonna go by ones.
no.
No, we're trying to go by
We're trying to go by 0.5 and there's not enough.
Oh, so you can't go by 0.5 then.
So we have to go by 1. Could we go by? It just won't be as pretty.
What about 3, 4?
Should we do 9? It could be 10.4.
What?
We're saying oh, so then I started.
You're usually You're usually accusing me of that.
I don't accuse you.
Sometimes
I'm right.
I don't like to talk about it.
Just do this.
We can all have a little fun. Maybe it's starting to say this for my name because she can't say it. So she says this.
It's 11. Yeah. You want me to fill out?
What is the line intercept mean of our graph?
This, where it starts.
The y-intercept
Is where x is 0. Is the height when x is 0.
Oh, is it just mine?
Yeah. Weird. I didn't notice yours too. Very weird.
Oh, that was very strange.
Oh, and the same thing I learned. Like this one is missing. Maybe they're going all the way there. Printing strange.
Yes.
Sometimes I'll have my geometry classes and something it's like they don't have any lines. They have these dot lines. They have the outline.
What is the relationship between the number of cups and the height of the stack?
May I take a peek at your? Oh, I see. What your graph is there. There we go. Okay, answering the questions. Rocking. Okay, continuing on. Good. Yeah.
The question is, Cicely, suppose someone says if you double the number of cups in a stack, the height of the stack doubles. Basically, why this thinking is wrong. Is wrong.
Because
You're only adding.
instead of twice, but the 9 is what
Yeah,
makes
instead
it
of
tough.
adding 9.
If you were stacking them like this, that would be correct.
Are you sure about that?
Pretty sure.
Measure them.
No, because 2.
I'm just being a
Doubling
baby.
it.
I know, but I can't measure it when it's like
Suppose someone says if you double the number of cups in a stack, the height of the stack doubles. Explain why.
doing some experimenting.
It doesn't like it doesn't
Start at 18?
grow from 10
Yeah.
to 20.
Oh, damn, you're right.
So
I don't know how to explain.
I didn't make mine.
When x equals 0, 0 cups. My y-intercept is when x equals 0, so when there's 0 cups, the height is 0.
The height is double.
0 turns. 0 cups.
There's 2 cups.
This is going to be really confusing to watch.
If the height was to double, you would be adding the amount of
You are not not
like when you
adding
But this is not that kind of data.
the
It's not that kind of data.
entire
If there was 0 cups, it would be nothing.
height
So it would be
of the
in smaller increments.
each time. Only
or
the
asking, I don't know.
2 centimeters.
I mean, yeah, I don't think it should be a line.
Top.
I would say the y intercept would be nothing. Or 0.
Or I don't know how to say it.
But it's fine. You don't have to add any more.
Can you like show your little graph?
Oh no, I'm gonna scan it and send it.
There you go.
But we're reading the questions aloud, so she's just gonna pick her.
Are you
Yes.
No, because
How are you doing? Like 3 days. Are you
Yeah, this is my last class. And my last day. Hopefully.
you feeling it?
You ready?
No.
No?
No.
It's not coming?
No.
It's not gonna hit you?
How would the graph
How would the graph be different?
if you repeated the experiment using small disposable Dixie cups? Explain the difference in steepness as well as the difference in starting points. It would start at a different height.
It would start at
Lower
like it is 8, but even though the number could be 0,
height and be less steep. Less steep. Because
This is the number of cups of 2 times 2, which is
Cups.
4. So I guess the x times 1 plus
Adds.
x.
Because it would just be like
Adds, not ask. Less
Do you know what I'm saying?
Without measuring, predict the height of your stack after 6 cups.
Yeah.
Okay, so we're at 4.
So 12.6
is 13.8. 15. Ten.
Because this is the height of the cup of the lip, and that's
6 plus, so 15 plus. Oh, wait, no, that's right.
Well, let's write the formula. So it would be 9 plus, so for 10.
And minus 1 times 1.2.
Does that work?
Because the 9 includes the first cup, so you can't take the.
That is right.
Did she make it TK
She did. I mean, like, I told her that she had to do it.
So then 10.
So for 10 cups, it would be 19.8. When
Say hi to Ohio for me, Sizzle.
Hey, also, we can't meet her on Saturday
as much as you can, and we're going to talk
because we're setting her up Cicely and she really needs it. Cicely's not going to be here on Saturday.
Or Monday or Tuesday or Wednesday.
We should,
The test is Thursday?
yeah, we should do Monday because I work Tuesday.
Wednesday.
This is the value.
I don't know when I work next week. I haven't been in it forever. Like in this.
Like, do you remember what?
She hasn't said anything else. She's not happy, but she's not mad. She just deposited $100 in my account and it took 36 off.
Your graph is interesting.
Oh. Which doesn't usually happen. I might have been 36 months too. Spent $25 at the box.
I have to pay
Yeah.
How are we doing?
Good.
Okay, so I'm going to ask you about number 3, the y-intercept.
So it's when there's 0 cups, what is the height of 0? Yeah.
0 cups, 0.
No,
I mean, like, there isn't really.
We learned about this kind of in that secret class. Yeah, me and Gabby over there.
Secret
We're
class.
taking secret classes on Saturdays
To
from
get the
8
math
from
certification.
8:30 to 5. It's a very long time. But she does this out at like 2, 3 o'clock. But just sit there from 8:30 to 3 o'clock for math for the secret.
Do the math test.
Yeah, to make the middle school math.
Oh, okay.
It's so fun.
But
Yeah.
it's really going to help you when it comes to answers.
Yeah.
Who provides? Is you would say.
Because if you take the middle school math test, you get like you should be told about that. No, so if you take the middle school math test
Or science.
or science, and then you student teach there for your senior year, they give you $10,000.
Oh, so you did the what's that?
It's called the seed grant.
Seed. I keep on thinking that you're saying secret.
Oh no, seed.
And I'm like seed grant. Yes. I thought secret.
Because they're offering classes for
Yes, I know the seed grant. Yes.
Yeah, but they offer those classes for free. It's so much fun.
I love math.
Because this is very much foundational stuff for that. No, I know.
No, it's 1.2. 1.3.
It's helping you to
Oh, yeah.
understand what you're doing.
It's very long.
Yeah.
Are you learning anything that I wouldn't be able to figure out on a test?
The problem is you only get a
That's
the wording. Stupidly, like, oh, shit. Like, it's really simple, but you have to figure out what they're saying.
Did you want
And they told
They actually give you that amount of time per question, or that's what you have total if you are. They like actually tell you which question. It's online.
It's a 5-hour test. There's 120 questions.
But now it's yours.
Sounds terrible.
Yeah, well, it's going to be fun. I'm like, oh, it's
No.
I don't want to have to start teaching in middle school. That's what's stopping me.
I'm fine with it. Whatever. I'm in high
I want
school.
to do elementary.
I'm fine with whatever.
I just don't want to not have ever not all that.
You're going to tell me.
I'm sure some groups.
They could still put me in the middle school next semester.
All right, so
No, it's only till 6.
we're gonna just show a couple graphs first to show different scales and different increments on the graph, so we can see if it makes a difference. So how about who was the 2? Whoever's going at your you went the 2. No, like his yours is different because it has to be. But just straight up started with 2. Which group was that? Okay, where was it?
For the y-axis? Yeah.
Who's the person that was paying attention?
So,
of those 3 groups that I said, I'm going to ask you to share because we had 3 different representations. And I needed to
what was it?
to do like a set aside who's going to be actually.
So their answer is 2. We're going to answer
Well, she's been asking me. She just wanted to know what it was. Do you want to put the graph up there?
You're lucky I like your scissors.
For some reason in this room, it's very weird. Teacher, because I don't know how it works. Well, they're all different. They all have some different ways of working.
Ooh, we might need to.
I'm not seeing.
Maybe we should turn off this light.
No, it ends up actually. The right button, right. What is that called? Light switch. And then light. Oh, there we go. You just never know. I'll make it a little bit larger to look at. So you can see. All right, so you can see their scale. It's always is a scale. Okay. So the scale on the y-axis is what? Increments of 2. 2. You see how it's increments of 2. So the graph. Take a look at how that slope works. Okay, thank you. The 2.5 group. So group 7. Who's your sharer? Quick, come on. And then group 6, you guys will be next. So be in the waiting. I need to jump. It's like impossible.
Well, she'll see
I need to do a little bit.
I guess it'll be helpful.
Yeah.
No, the dots are really showing, but the numbers aren't so much. Okay, so it's great. Oh, you know what? If you did this, your hand was there and it worked. Made it darker. Can you see what the increment is? Dun, 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 dun. It will be 2.5. 2.5, 5, 7.5, 10. So the graph a little steeper. Okay, and then thank you. Group 6 asked me a question while they were working. And they said, can we start at 9? And you can. But if you have this zigzag line here, this zigzag line means basically the y-axis was like compressed. So you can start at any number if you have the zigzag line. And then they have increments of 1. Okay? So theirs is not as steep as the others because increments of 1 instead of increments of 2 or 2.5. But this is totally acceptable to have this zigzag line to show it's compressed. Fabulous. Thank you for sharing. Okay, let's talk about these questions now. So the questions on here. So the y-intercept, according to this situation, what does it mean? What does that y-intercept mean? Okay, so since you worked in groups, we'll do this. 2 of clubs. What did you guys say that the y-intercept meant?
You said that when the line crosses the y-axis, it would be as 0 cups.
Okay, so when the line on your graph crosses, crosses the y-axis, then that would be at 0 cups. Anybody have an issue with that?
Well, that's what we were talking about originally as well, but you can't have a height if you have 0 cups. The height would be 0, and it's not. So we were talking about how maybe the height, the y-intercept is representing the height.
So we can pull that. So
That's not what we were talking about. We talked about it later after we did.
Well, no, just so we can show that it's not going to 0.
Oh, sure. Yeah, that you can show. Sorry, I was like, we didn't do what we're talking about. But how the height is at 0 is actually, cups is actually just measuring the height without the rim of the cup, because the rim of the cup is what you're actually adding each time you add a cup. So we said that it's just the height of, that at 0 cups, it's the height of the non-rimmed cup.
Okay, so let's just go ahead and talk about the y-axis. If we were to continue this, it is at 0 cups. So the height of 0 cups should be
0.
0. It should be at 0. Some of your graphs actually work out that way if you use, well, no, it shouldn't. If you didn't do the zigzag, you just started at 9, then it's going to be all nice and pretty. But actually, if you had that zigzag on there, then you would see that it actually wouldn't go to 9, it would go to a different number. And right now we're not even going to address that, but I want to talk about like the meaning that you were talking about. So 0 cups should have a height of 0, but yet our graph, the y-intercept isn't, the 0 cups isn't at 0. So let me just tell you, there are 2 different, thank you, there are 2 different ways of thinking. What we are talking about is called experimental mathematics, right? We did the experiment, and we say 0 cups would be 0 centimeters, right? But if we're going to go with that graph showing the line, that's called theoretical, and you don't need to know those, I'm just telling you. It's called theoretical math. It's the theory behind it. Like, who cares about the context of the problem itself? If we just continue the line, the y-intercept would be at this particular number. Okay? But with the experiment and using the context of the experiment, 0 cups would be 0 centimeters. So it wouldn't be the typical straight line. Okay? That's why it ends up kind of being, some groups are like, wait, what are we talking about here? So on the graph, you can have, for this answer, you can have either one as long as you can justify it. If you said, like, the y-intercept of your graph would be a certain amount, and that would be because that would be the height in the experiment that you talked about, the explanation. I'll talk about that in a minute. I don't want to get into it just yet. But then you can say also, like, but if we were to talk about the experiment of 0 cups, the height would be 0. So that would be where our y-intercept would be using experimental math. So either one is acceptable. All right, question 4. The relationship between the number of cups and the height in the stack. So how is that changing? And just because we have a couple of different reasons, did anybody have consistent change from one cup to the next? Holy moly, that's kind of impressive. All right, so what was your increase each time? 1.3. 1.3 centimeters? In group 3, what was yours?
We're 1.2.
Sorry, group 3.
We're 4.
Oh, 4, sorry. That's why you're looking at me. I'm going 1, 2, 3 in my head, sorry.
1 centimeter.
1 centimeter each. And you also had the same increment at each time?
So 1.2.
1.2 centimeters. Okay. And then others were a little bit off. And why are these not the same? And why do we not have other groups that have the same increment? You had 1 centimeter also?
Yeah.
Okay. Why do we have something different?
You just said that like there's styrofoam cups, so they could have been made a little bit off. It's not an exact.
Yeah, the styrofoam cups, first of all, have been used for a couple of years too. So they are kind of a little bit beat up, so they might have been damaged, so they're not quite as tall, some compared to others. What else?
They kind of go at an angle, so measuring it's like straight up and down.
Measuring that height could be a little bit tricky because we're not necessarily measuring exact perpendicularity. Okay. What else? I don't know about you, but when I'm measuring these kind of things, even trying to figure out like the end. Did you guys know that the end of measuring devices is not necessarily zero?
That's what we were one off from everyone else because of that. We couldn't find the zero.
So because we don't know that the end is actually zero, then a lot of people will start measuring at like 1 centimeter and then continue on. But you've got to remember to compensate and subtract that 1 additional centimeter that you entered. That happens, just so you know, in elementary school when they have those wooden rulers. The wooden rulers, just like Elise was saying when it comes to the styrofoam has been kind of beat up. Those wooden rulers kind of get beat up. And so the ends where zero is supposed to be is not necessarily zero anymore. Some of the rulers have like a space and then a line for zero, so the beat up part won't matter. So there's lots of different things. So then also, measuring with the measuring tape. Trying to like get that little bend to get it so that it's exact is not perfect. Somebody else in one class said, well, maybe when we measured, we didn't actually push the styrofoam cups like into each other enough so that there was some air in between, so maybe one kind of was sticking up a little bit more than the other. So they're not going to be exact. But in general, we have something, like some of you would put in here, like each cup increased by 1.2 centimeters or 1.3 centimeters or 1 centimeter. You that don't have the same measures each time can kind of average, do like an eyeball average about, 1 point whatever centimeters. That would be fine. Okay. Number 5. Someone says if you double the number of cups, the height of the stack doubles. True or not?
No.
False. Okay, so if I pull your card in your group and you get to these questions, that's okay. We don't have any ones. 7, the clubs. Who's your club? Okay. So why is that wrong? Hey, she's the club, so she could explain.
She's telling me to take it for her.
Okay, pull a friend so you can talk. So find out from her. So then you're gonna be the speaker still. It's wrong.
Okay. It's because like if you double it, like it would have to like stay on top of it.
If you double the height of a
Yeah.
cup
Yeah, you would have to like stack it like this instead.
inside, would you agree with that? I saw different representations. These guys had this view and show it. Yeah.
Because like this is like
They're
the first
stacking them
one.
like the way I said not to
Shit.
stack. But to prove that would be doubling the height. Over here, well, you did something a little bit different. Somebody over here did it.
False.
Well, we didn't know how to explain it, but
No, but how do you show it? Like I saw somebody do this, and then was it you who did it?
I don't feel like we're
we just did like hypothetically.
Was that your group over here? And you were group 6. There we go. Yeah, that was that. Sorry. So do you see? Go ahead and show again, Drew. Just another way to show, like that would be another way to show doubling the heights, and so on. Okay. Tools, not toys. Thanks. Tools, not toys. So, doubling it. Is there another way that you can explain that? I know some people were looking at data. Actually, I think it was this group.
We said, like, for example, I don't really know if it's like either, but we said if you have 2 cups and add 2 more, therefore doubling it, it only grows by 2 centimeters, not 10.
Yeah, and so, like, if you look at your graph, or your table, you can see
2 cups is 10, for us it was 10 centimeters, and like by adding 2 more, it's not going to be 20 centimeters, it's going to be 12.
so you can use the data that you have on your tables. Fabulous. All right, so how would the graph be different if you repeated the experiment using small, you know what small disposable Dixie cups are? Those little typically used for bathroom cups. How would the graph be different? What if your group didn't get there? Okay, so 3 of diamonds.
Oh, that's me.
Okay.
So we were saying that the steepness would be really shallow because when you're measuring these cups, you're really adding only the rim of the cup every time, not the actual cup, and those Dixie cups basically don't have a rim. So you're
That
adding
little roll
very,
part
very,
at the top?
yeah, you're adding very, very little height each time, so it's not increasing a lot, so the steepness is going to be actually really shallow. And then also, just because of the initial height is so much smaller than these cups, it'll start at a lower height on the graph.
So your graph is not going to be like, this is the same what we saw with the other cups, the styrofoam cups, but I heard starts down lower and is
Shallow.
flatter, more shallow, less steep. Lots of different ways to explain that change in slope. Okay. No measuring. You were purposely only given 4, so you couldn't actually use them. Although I've had classes before, they're like, give me 200 cups. So they would do this. So, predict. Did you think about it? Yes. Did you do it? Okay. What would the height be? And because people have different increments, so what would that height be for the stack of if you get to 6 cups? So 4 of spades. Did you guys get that far? Who's your spade?
Oh, me. Yeah. For 6, it'd be said 14 centimeters.
At 14 centimeters? Do people have something in the general area of 14? Yes? No?
No.
And it could have been like, because if you had a 1.3 centimeter increase, then you may be more like 15 to 16. Yeah. The larger increments, that's going to be larger. So, if you had 10, I'm just going to ask, could you just take what 1 cup is and multiply that by 10?
No.
The height of 1 cup and then multiply it by 10, because that would be, and I'm just going to start stacking those cups up. That would be 10 cups stacked up, right? So that wouldn't be right. So we would have to take, is that a formula? Did that one? So you would have come in before you actually got to that 10 cups. So this problem sort of algebraified a little bit because we saw like at 1 cup, 2 cups, 3 cups, you found those, right? And then it was like, okay, what's one that's a little bit further down the line? And then what's one that's much further that it's harder to actually calculate? You could add 1.3, 1.3, 1.3 until you got to 10 cups, continue your table. Did anybody continue your graphs? Could you continue the graph until you got to 10 cups and get an estimate? Sure. Same thing with 6. Did anybody continue their graphs with 6? No? Just did mental math? There we go. So you can use like the change. Oh, let me tell you about this. So that change, whatever your number was, that's called the rate of change. Okay, something you need to know. It's called the rate of change. For every cup that's added, we're increasing so many centimeters. That's the rate of change. So it's kind of like a unit rate. For every 1 cup added, we increase our measurement, whatever your increment was, whatever that was. That's the measurement of your rim, right? So for every cup, that's called the rate of change. So what question was that answered? 4. So number 4, that's called the rate of change, whatever your answer was for number 4. And they're different for the different groups. So when it comes to finding a formula, we're going to actually doing that. And even talking about 10, we're going to kind of hold off from doing that just because I want to have I want to have enough time to talk about the Algebra 5 project. We're going to be continuing with this. Like part 2 is going to come up after the exam, so that's going to be like a week and a half from now. So keep this. We're going to revisit it. If you need to jot something down and help you remember what you did, do that. And then we'll talk about the Algebra 5 project. There's a folder in the course information folder, like where you get the study guides and stuff, which by the way, the study guide is there. The study guide is there for exam 2. And then there's a folder for Algebra 5 project. This is kind of a big deal because it's worth 60 points. But it's not really a big deal because you guys did such an awesome job with coming up with Algebra 5 problems for your arithmetic problems last week in class. You know when you have like the green paper with your simple arithmetic problem, you had to write an Algebra 5 version of it? That's basically what you're going to be doing for your assignment, but then you're going to do a little write-up. So here's the problem. I told you already a little bit about it. The project goes like this. You're going to pick 3 different tasks for very elementary word problems, okay? They require a single numerical answer. I'm recommending if you go down to really low levels, it will make your life so much easier. If you do some simple addition, subtraction, multiplication, or division. I would not do multi-step problems. You know what I mean? Really, really basic. Makes life so much easier for the assignment. Could you use them? Of course. But algebraifying it gets to be a little trickier. All right. So you're going to convert your word problem into an opportunity for pattern finding, generalizing, and justifying, the 3 things that we talked about in the last class. Study work we've done in class about generalizing patterns and formulas. You'll be able to apply those things to this assignment. Okay. You're going to hear it's like going to be a broken record in your paper. Some of it is a little bit of a broken record because you'll be writing paper. Your Algebra 5 tasks, be sure to require students to find patterns. That will be requiring them to write their equations, right, for each situation. Then they have to find patterns. Represent the generalization. That'd be their formula of what do you generalize, like what happens each time. And then justify their thinking. Use your classmates. Ask people to help critique your work.
So finding a pattern would that be like having them try to table?
Or write their equations. Write an equation for each one, then they can see what's happening every time. We can see, oh, we added 4 each time, like with the earning $4 or whatever, and then you have to figure that out. So yeah, you could have them do the table, but it's a little bit easier for the to represent. Yes, that's why if you have equations, then they say, oh, the thing that's varying needs to be the variable. So that makes it a little easier than the formula and trying to go in explicit. Like, ooh, that's what's going on. All right. Again, do the students have to analyze a collection of cases, so different situations, so different numbers changing the size, right? Do they have to identify a pattern and generalize, and then apply it to this situation? So same thing, repeated again and again. All right, so besides algebraifying those tasks, you're going to write a paper. So in the paper, you're going to write details about the 3 activities that you started with. So those 3 tasks or problems, you're just going to like put it in your own words. That's all it is. Put it in your own words. That's all that is. Okay? So when it says detail the 3 activities, means you're going to summarize what happens in the problems. And then what did you do to algebra each of the activities? I had the students do this. Then the students had to do this. Then I had them do this. Okay, what did you do? And then you need to give a rationale for how each of those actually develops algebraic thinking. What's the parts of the algebraic thinking that we've been talking about? Finding the pattern, generalizing and justifying. Okay? How did those problems develop those three things? It ends up being kind of redundant. You'll get really good at it, and there's a reason for it because we want you to be really good at it. Okay? Paper should be 3 to 4 pages long. Just don't have a heart attack. I'll explain why. 12-point Arial or New Times font, 1-inch margins, double spaced. So all that stuff just so we make sure we don't have people writing like huge font and like gigantic margins so they can get their 3 to 4 pages. Include your arithmetic and algebraic tasks as an appendix in your paper. It doesn't have to be an appendix. It can be like as an introduction. So that's a big chunk of your paper right there. If you're going to have three problems, the 3 original problems with the algebraic version of it, it's going to be a big chunk of your paper. Okay? So like I said, it doesn't have to be an appendix. I'm not real particular about that. You can have that at the introduction of your paper. It'll be submitted on Blackboard on November 1st. There is something else that's going to be a written document, and that will be presentation. You're going to present your work to the class on November 1st. Make a PowerPoint presentation, it says. It doesn't have to be PowerPoint. It can be other types of presentation. This is a little bit older, but I was going to change it, but I'm like, I don't want to list all the different presentation types. So if you're going to use Prezi or whatever it is, you're going to use Google Presentations, you can use all those things as long as it's a presentation. And all your presentation is going to have is your arithmetic problem and then the algebraic version of it. And then another slide, arithmetic problem and the algebraic version of it. And then the third slide, arithmetic problem and algebraic version of it. Okay? You're going to give a little 2-minute presentation. That's all. Super short. You're going to share how you algebraified one of the 3 arithmetic problems. So you're going to talk through kind of what you had in your paper. How did you algebraified it? I had the students find a pattern by writing this. I had the students generalize by having this included in the problem. And then I included this in the problem to have students justify their thinking. So it's just, you're going to hear 24 other versions of the same kind of thing. And then if you have time, you can just read through those other problems if you haven't run over time.
So when we do for the paper, for the written part, is that just one document with the algebraified and then the 3 pages? So we're not turning in 2 separate documents, we're turning in one, correct?
No, you would have 2 separate. One will be like a paper,
yeah,
so
and then the
Word or whatever, and the other one would be whatever your presentation
okay.
is. So
I
we'll
thought you were
submit them separately.
Okay, I thought the 2 things that we were doing for the paper were 2 separate documents. That's why I got confused.
No, it's part of the
Okay.
So, the briefest presentation ever. Some people are like, oh, I feel like I'm just reading those slides, and that's a horrible way to present. You kind of are, if you get to this point. If you take your full 2 minutes, and when you're talking about how you algebraified your one problem, then you will be done. Because we need that in order to be able to transition and have the next person be able to present. Okay? Yes?
So we have all 3 problems on there, but only on the PowerPoint.
Okay.
Because if you finish your explanation, then you'll go through and just share the other 2 problems.
Okay.
If you've got time. You can be, this is where you get a chance to be creative when you're doing your presentation, cute it up, do whatever you want to do, or like me, I'm not so cute with stuff, so mine wouldn't be so cute. When it comes to your paper, you will feel like, oh my gosh, I'm writing the same thing over and over again, but it will be the same thing relating to that problem. Same thing relating to that problem. So that you're getting this ingrained. So then when you have to take an exam, you'll even be better at it. Although you guys were really good, and this algebraifying will show up on this exam that's coming up, because you did such a great job with this in class. This just solidifies it even more. If you have questions, of course, feel free to ask.
Is it gonna be due before class then, like on
Yes.
Blackboard,
Yes,
and then the presentation
that's a
is
good
on the day?
presentation. Everything will be put on Blackboard before class on November 1st, because then what I'll do is I'll go into Blackboard and I'll just click
Okay.
and
So
then open
technically
your presentation right
The
there.
31st. You want it in there? Or
No,
like
it
just
has to be
before class? So okay.
Just
the
don't
day
do it
before.
during class.
Yeah.
Because that's annoying for me if someone's doing something for their future class that, I've got a presentation in the next class, I have to write it up. That's not cool. Someone said to me, you had a math test today, huh? I'm like, yeah. Oh, they were studying during class. I'm like, okay, that's your job to stop that. Like, what? And if it's okay, if they're good with it, yeah. But usually they're like, you were studying, you're not supposed to be studying. I'm like, then tell them not to. I was kind of confused by that.
Oh, why would she?
So here's the thing I want to also tell you.
Someone over said that.
I would recommend kind of getting a start on this because, okay, so we have class on Tuesday. We're done this week. That's kind of good. So Tuesday we're going to be preparing for the exam. You'll need to bring your study guide, hard copy, or electronic, either one. Just like last time, if you're doing electronic, I would download it ahead of time in case we have some Wi-Fi issues. And then, you have a homework assignment. It's really short. It has to do with the meaning of more. So, which ordered more? There's like a problem. They're just 4 questions. It's really quick. You can just handwrite it. You don't have to print it. But you need to bring it in class on Tuesday because we're going to grade it in class so you can have feedback for the exam because Thursday is the exam. Okay, so catching up. So then the next Tuesday will be the 25th. We'll have class, regular class. The next class is the 27th. We will not have class. Don't cry. The 27th we won't have class. I have a conference to go to. So I won't be there on the 27th, Thursday. October, like in 2 weeks. So here's what.
Oh, that's good.
I have a conference. I just want to teach that day. I have a conference to go to. And I scheduled the whole semester so it works. That's kind of why we have this 1 year weird lesson today that's not going to be on the test. But the reason I'm saying that you might want to get a head start on it is because since we don't have class, the class immediately before, because that next Tuesday, November 1st, you might want to at least get a head start. If you don't want to do it before the exam, at least do it like the weekend before the 25th. Not this weekend, but the following weekend. Get a start on it. So if you have questions, you can ask it in class Tuesday. Not that you can't ask questions via email, but sometimes it's easier face to face. All right?